Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. And the agenda behind today's video is to take few number of questions based on the concept of the Nyquist stability. The different varieties of the problem which we have brought in today's class had come from the electrical as well as instrumentation as well as electronics. So more or less the good idea of the Nyquist plot we are going to create in today's class. I would request to each one of you, because of my medical issue, I was not supposed to take the class today and as well as tomorrow, but probably we are going to have the classes in the same schedule which we had earlier, and that's nothing but the 3 to 4 p.m. So what I am saying, tomorrow as well as day after tomorrow, I had the planning that I won't be able to take the class because of the medical emergency, but now I am able to take the class. So obviously my timing would be remain same, and obviously we are going to spend somewhere one around in the daily basis, including today, tomorrow, day after tomorrow. Agreed? So focus over the first question first, and then we would move forward. This problem had been experienced by the electrical people. In year of 2009, the problem was framed by IIT Roorkee. Let me read the problem word to word, and then we would try to smash this problem out. The problem states, the polar plot of an open loop stable system is shown below. The closed loop system is. The four different options were attached along with this problem is being always stable, marginally stable, unstable with one pole on the right hand side of the S-plane, unstable with two poles on the RHS plane. So tell me, what would be the best most answer, or what could be the best most answer which we can retrieve after solving this complete problem? Read the problem carefully. This problem should not take more than 90 seconds to crack it out. Read the problem carefully and tell me what would be the best most answer according to you guys. So let me do one thing. Let me bring this problem towards working board, and we would try to smash that problem there only. Just a minute. Yeah. No issue. What had happened? Just a minute. So let me take this problem towards working board, and we would try to smash that problem there itself. I need at least one response from you guys. Tell me what could be the best most answer for this given problem. So at least one input I want from you guys. What could be the best most answer for this given problem? The answer have started coming. As per the Anindya Bose, the answer could be C. Anyone else apart from the Anindya? Anyone else? Just try to understand. This problem, had it been a Nyquist plot or had it been a polar plot? I would like to have the input from each one of you. The draw which had been given over the problem is been a Nyquist plot or whether it had been a polar plot. Obviously, sir, it had been a polar plot. Many of the students used to have that doubt again and again. They are not able to distinguish whether the Nyquist plot had been given along with this problem or the polar plot had been given along with the problem. My dear friend, until and unless you do not have the closed loop pole, or until and unless you do not have the closed plot, no, forget about the Nyquist plot. It's going to be polar plot only, because the polar plot starts from 0 plus and goes till infinity plus, whereas the Nyquist plot goes to, or it starts from 0 plus, goes to infinity plus, goes to infinity minus, then comes back to the 0 minus, and again come back to the 0 plus. So put together, it had been a closed loop. So what had been the difference between the Nyquist as well as the polar plot? The Nyquist plot had been the extension of the polar plot, where the value of omega goes from very negative most positive most positive value. Could you understand what I am saying? So the answer have started coming. The people are saying C. So one thing is been quite sure. Once you will focus over this problem, few of the important point I would like to write. This problem had been the polar plot. How did I know about it? Because it was a open plot. It was not getting closed properly, or virtually speaking, it was starting from omega is equals to 0 and was going till omega is equals to infinity. Yes, sir. Anyways, little change I would like to introduce within this problem. This has not been omega is equals to infinity. It had been omega is equals to 0. And once you read this problem carefully, In this problem, they had been talking about the closed loop stability of the system. It had been communicated earlier. Whenever we talk about the closed loop stability of the system using the polar plot, what we do, we extend the polar plot even into the negative values of omega, and which had been the Nyquist plot, and with the help of Nyquist plot we calculate the stability. So nobody should assess the stability by watching this plot itself. They should draw the extension of the polar plot, and that had been the Nyquist plot. So what I am saying, specifically in this problem, the next important point should come in our mind. They had been talking about the closed loop stability. Closed loop stability. So we should have the Nyquist plot in our hand, or I can say it had been the extension of the polar plot, Nyquist plot in our hand. In Nyquist plot, total 4 number of segments we had. The first segment where the omega was starting from 0 plus and going till infinity plus, or I can say the value of omega was strictly positive. Similarly, the second segment was when the omega was moving from infinity plus to infinity minus. And similarly, the third segment was when it was moving from infinity minus to 0 minus, and similarly the fourth and the last segment was when it was moving from 0 minus to 0 plus, 0 minus to 0 plus. Once you will read this, or once you will visualize this polar plot, one thing has been quite sure, if we will talk about the segment number 3, how the segment had been taken place. We wanted to cover the complete entire region of the right hand side. For that we took the semicircle had the radius is equals to of infinity, sort of this we had, no? Here we had omega is equals to how much? It had been omega is equals to infinity plus. Here we had omega is equals to of infinity minus. Here we had omega is equals to of 0 minus. Here we had omega is equals to of 0 plus. And they had been bifurcated in terms of the different sections. Here we had the first section, 0 plus to infinity plus. Here we had the second section, infinity plus to infinity minus. Here we had the third section, infinity minus to 0 minus. And similarly, here we had the fourth section, 0 minus to 0 plus. The 4 sections we had. Let me call this as a first section, second section, third section, as well as fourth section. In this problem, once you'll read this problem carefully, one thing has been quite sure. The third section used to be the inversion of the polar plot itself. So you had to take its inversion only. Once you take its inversion, now how the inversion of this polar plot would look like? It would look something like this. As it had been 0 plus, so obviously it had been 0 minus. You yourself would be able to understand. It lends up to the 0 minus. Once you'll see this plot, one thing had been quite sure, at least the infinity plus as well as infinity minus had been located at the same point. That means the segment number 2 of the polar or Nyquist plot had been overlapped at the same point, and that's why it had been just a point itself. Agreed? Now you yourself would be able to understand, sir. 0 minus and 0 plus had been at 2 different places over the polar plot. Why it takes place? It takes place only and only if you have more than or maybe one or more than one type of system. So 0 minus is being kept over here and 0 plus has been kept over here. And that's why I used to say even the radius which we taking the omega is equals to 0, that also used to be infinity only. So what we are going to do, from 0 minus to 0 plus all the way, we would be bringing a circle, or I can say the semicircle. And how much movement would be taken place? The movement would be precisely 180 degree. Would it be in clockwise or would it be in anti-clockwise? It would be in clockwise. So from here, at least one of the important conclusion we can retrieve, whenever you have type 1 or more than type 1 system, in that case 0 minus as well as 0 plus would be placed into 2 different regions. So you had to start from 0 minus and you had to reach from 0 plus, keep in mind, in the clockwise direction. The reason as well as derivation, I am not discussing much about it, but in the clockwise direction, that's the first thing. And at the same time, how many rotation has to be taken place, that fully depends whether it had been a type 1 system, whether it had been the type 2 system, whether it had been the type 3 system. For type 1 system, the rotation is simply going to be 180 degree, and that too clockwise in nature. Could you really understood what exactly I wanted to communicate through this problem? So probably you guys would have the clear-cut idea about this problem. Now what we have been talking about? We have been talking about the stability of the system. Stability of the system can be easily assessed using the concept of principle of augment, where the n had been the number of encirclement of the critical point. At least for the closed loop stability, the critical point had been -1 plus j0. Similarly, what had been the P over there? The P had been the number of open loop poles which are been there towards right hand side of the S plane. And similarly, the Z had been the number of closed loop pole which had been there towards right hand side of the S plane. So at least in this problem, the two data can be easily assessed. As the intersection over the real axis is being at 1.42, so obviously -1 is going to be somewhere here. And once we'll be talking about the encirclement of this critical point -1, what we are going to do over here, we are going to take a ray out from -1. How many times the encirclement had been taken place? It's just same as the number of intersection of the Nyquist plot. How many times the Nyquist plot had been intersected? 2 times, and that too whether it had been clockwise or anti-clockwise. So definitely it had been in clockwise direction. So as far as the n is being concerned, the n is simply going to be -2. N is simply going to be -2. Agreed? No? N is simply going to be -2. And similarly, if we'll talk about P as well as Z, easily we would be able to get each and everything. What had been the P over there? The P is being said the polar plot of open loop system is being stable. What does that mean of it? That means if you would be taking the reference of open loop transfer function GSHS, forget about its numerator, just focus over denominator. None of the pole had gone towards right hand side, and hence the value of P was also 0. And it had been Z is equals to -2. The closed loop pole towards right hand side had been exactly 2. Has been exactly 2. So may I know what had been the best most answer for this given problem? The D is gonna be the best most answer. I do not exactly know how you people have given the answer as option C. Option C won't be the correct answer. Option D is gonna be the correct most answer. Correct most answer. Agreed? Let me briefly discuss what exactly I wanted to communicate through this problem. This has been a problem where the polar plot for a certain OLTF is being clearly given, and they had been asking about the closed loop stability, taking the reference of this OLTF. So obviously, whenever we talk about the closed loop stability, the given polar plot has to be extended, and there the Nyquist plot has to be drawn. For that, the 4 number of sections we used to have, the first section is very same as the polar plot, and even the third section is very same as the polar plot. We used to take the inversion of the polar plot. Like here it had been a polar plot, we have taken its inversion, and once we have taken its inversion, one thing has been quite sure, at this point both had been meeting together, and there the value of omega had been infinity plus. That means the infinity plus as well as infinity minus has been lying at the same point, whereas the 0 minus had been lying somewhere else. What does that mean of it? That means 0 minus and 0 plus has not been at the same place. The type of the system is at least one type system, type 1 system, at least I am saying. Now once you will find, okay sir, 0 minus been there, 0 plus is been there, so obviously we had to connect it from here to here with the help of force segment, and the force segment says the movement would always be the clockwise. That's the first thing. Secondly, how much angle it would take? It could have been like this also, no? It could have been like this also. It could have taken 180, it could have taken 540. So according to it, it had been clearly said the number of encirclement or the number of movement of the angle is being 2n plus 1. What I am saying, 2n plus 1 into of 180 degrees. Simple, as simple as this. As simple as this. Could you understand? So forget about this. In future, we would be taking few more number of problems. There I would be discussing this thing in the great detail. So I would like to ask from each one of you, till this point each and everything is clear, or still you guys are having certain amount of doubt. If you had certain amount of doubt, you can put it over the live chat, and then we would move forward. So Ayo, good afternoon sir, but that had been the wrong answer. Anindya Bose, as per you the answer is being C. Again that had been the wrong answer. Agreed? So I think it's the right time to move forward, taking the next question. So let me do one thing. Let me bring the next question in front of you, and we would try to smash this problem out. It had been comparatively a better problem. I won't say it's a very difficult problem, but comparatively better problem, and you can expect this sort of problem in near future. The problem had been experienced by the electrical people. In year of 2019, the problem was framed by IIT Madras. Let me read this problem carefully, and then we would try to learn how we can smash this problem out. The problem states, the open loop transfer function of a unity feedback system is being given by GS is equals to of pi e to the power of minus 0.25s divided by fs. In GS plane, the Nyquist plot of GS passes through the negative real axis at the point. the 4 different options were attached along with this problem. It had been a type of MCQ. That means out of 4 different options which had been given along with this problem, only one option is going to be the correct option. Option had been minus 1.25 comma J0, minus of 0.75 comma of J0, minus of 0.5 comma of J0, minus of 1.5 comma J0. Anyways, as they have been talking about the intersection over the real axis, obviously the imaginary part has to be 0. So deliberately they have wrote the imaginary part also, and there everywhere the J had been fed with the multiplier of 0. So at least in terms of this multiplier factor, we cannot make any decision out of 4 which could be filtered out, but just focus over its real part and tell me what could be the best most answer which we can get out of it. Let me do one thing. Let me bring this problem towards working board, and again we would try to smash that problem there itself. This has been the next question. So the next 90 seconds had been given to you guys to crack this problem out. If you are not able to do so, I would be clearing the each and individual doubts regarding this problem. Read the problem carefully and tell me what could be the best most answer. And I won't say it had been a very difficult question, but I have seen in past 4 to 5 years, this sort of problems had been designed repeatedly, where you had the factor of e to the power of minus std, either the factor of delay, either the factor of advancement. So let me start with the solution. As far as the open loop transfer function is being concerned, which has been given in this system, is being gs is equals to of pi e to the power of minus 0.25 s divided by of s, and they had been talking about the intersection point over the negative real axis. Anyways, one thing has been quite sure, as you had been talking about the Nyquist plot, where the study is being made over the frequency domain. What we are going to do, we are going to replace s with j omega. Although in this problem they had offered OLTF in S domain, but now it's my responsibility to change the domain of study from S domain to the frequency domain. Let me do so. Yes, so what I would be doing, I would just be feeding S with j omega, and there the frequency of analysis would be changed to the frequency domain, and here it becomes pi e to the power of minus 0.25 j omega, and towards denominator side again we are going to have j omega. In this problem they had been clearly said that it had been a open loop system, unity feedback system. That means the feedback path factor for this particular system is being HS is equals to of 1. So rather writing this as GS, you could have written this as a GS into HS, because if you'll bring HS, then also the 1 gets multiplied both other side and the resultant would remain very same. So nobody should get confused, sir. So far for us the OLTF was GS HS, but why now you are taking the reference of GS alone? My dear friend, when you have been talking about the unity feedback system, by default HS becomes 1. In that case, either you can refer the OLTF of the system as a GSHS or simply GS. Choice is yours. So the answer have started coming. As per the Amit Kumar, the answer would be C. Yes. In this problem, they had been talking about the intersection of the real axis. May I know what does it mean by the real axis, and that took negative side? See, in polar plot, we had the 2 axes. We had the real axis as well as we had the imaginary axis. We had the real axis and we had the imaginary axis. And over this, we were drawing Gj omega, Hj omega, where it had its magnitude. What does that mean by the magnitude? The magnitude is nothing but the radial distance from the origin. And similarly, we also had the phase. I repeat, we also had the phase provided by the Gj omega, Hj omega. So what does that mean by the phase? How much phase is being provided by the system at the different operating frequencies. If we'll take the reference of the standard angle, may I know which angle it had been? 0 degree. Whenever you go forward into the anti-clockwise direction, the angle is being represented positive. So this angle is going to be plus 90, this angle is going to be plus 180, this angle is going to be 270. Similarly, if you take or if you move forward into the clockwise direction, the angle is being represented in terms of negative, so 0. And how far we have traveled? 90 degree. So the effect is being 90 degree into the clockwise, so obviously it's gonna be minus 90 degree. Similarly here it's gonna be minus 180 degree, and similarly here it's gonna be minus 270 degree. So whenever in future, if they refer, I repeat, whenever in future they refer, find the value of omega at which the given GS HS or maybe GJ omega HJ omega intersects to the positive real axis, negative real axis, positive imaginary axis, negative real imaginary axis, always take the reference of the angle line, because in positive real axis the angle would be provided by the system would be precisely 0 degree, and similarly intersection over the negative real axis, the angle offered by the system would always be minus 180 degree. Might be the system might be intersecting at this point, this point, this point. So what had been happening, the magnitude had been keep changing because the distance from the origin is being changing, but the angle had remained same. So what I am saying, whenever they used to talk about the intersection over the negative real axis, positive real axis, positive imaginary axis, negative imaginary axis, I would only suggest one thing, take the reference of angle line, and here the angle line had been minus 180 degree. Here the angle line had been minus 180 degree. Although rarely the problem would be framed where they would be asking the intersection of the positive real axis, because the positive real axis is not meant for my case or my calculation, because in stability basically I worry more about the intersection over the negative real axis. Anyways, keep aside each and everything. So what we would be focusing, first we would try to get, just try to understand what I am saying, first we would try to get the value of omega at which GJ omega HJ omega had been crossing to the minus 180 degree. So what we had been doing over here, we would take, or we would talk about the angle offered by the GJ omega HJ omega precisely equals to of 180 degree. 180 degree. May I know how much angle would be provided by the pi? Pi had been a positive real value, so obviously there would not be an introduction of the phase because of pi. Because of j omega we have already seen earlier, because of 1 upon s we would be having the introduction of the phase is equals to of minus 90, because of 1 square minus 180 degree, because of 1s cube it would be minus 270 degree, or in general I can say 1 divided by s has been raised to the power of n, the angle would be provided by the system is equals to of minus n into of 90 degree, and that remains independent from the operating frequency omega, whether the omega is been towards lower side or whether it had been towards the very higher side. Could you really understood what I am saying? So this factor had been nulled out, and similarly if we will talk about the angle which had been provided by this factor is being minus of 90 degree. Now focus over the angle which had been provided by this factor. First we can expand the e to the power of minus j theta in a form of de Moivre's theorem. So what we are going to do over here, this factor could have been taken as, just focus over this factor. This factor could have taken as cos of omega, yes, and similarly along with omega we had 0.25 omega, and e to the power of minus j theta stands for cos of theta minus of j times of sin theta, and here the theta had been 0.25 omega. 0.25 omega. Could you really understood what exactly we have been talking about? Yes sir, we are able to understand it. Similarly, what about the angle which would be offered by this system? First thing is being quite sure, the real part is going to be positive, and similarly the imaginary part is going to be negative. What does that mean of it? That means this particular complex number would be placed in the fourth quadrant, where the real part would be positive and imaginary part would be negative. So the angle which would be offered by the system is going to be pure negative, because easily we can start from the positive real axis and we can go into the clockwise direction to reach to that point. So the angle measurement, because of the factor e to the power of minus j theta, would always be negative, So obviously let me know how much angle it's going to get. So simply it's going to be minus, no doubt, at least at this moment of time it's simply going to be tan inverse perpendicular divided by base. May I know which factor is going to be the perpendicular factor? Obviously the perpendicular factor is going to be the imaginary factor. So simply here I would be having sine of 0.25 omega, and here it had been cos of 0.25 of omega, 0.25 of omega. Agreed? Now in the next case, what we have been doing over here, you could have taken this as a minus 180. See, many of the times I have seen the student do also have the doubt, sir, when we take plus 180, when we take minus 180, keep in mind there would not be any change in answer whether you take plus 180, whether you take minus 180. But deliberately I have been taking this as minus 180 because in future the minus 90 would be shifted towards the left hand side, and this has been negative, this would become positive, and hence the angle would be keep reducing its magnitude. Could you understand what I am saying? Now there had not been any specific logic why I have brought this value as negative, but what I am saying, if you will bring minus 180 as well as plus 180, no, there would not be any change in the answer itself. Yes, there would not be any change over the answer itself. Let me move forward. And one of the disastrous part which we can do over here, keep in mind the resultant would be in a form of radians. So what you had to do, you had to convert the resultant in a form of degrees. So what we would be doing over here, simply minus 10 inverse, here also it's been 10, 10 and 10 inverse is going to go out, and the factor which had been left out is simply going to be how much? It's simply going to be how much? Get it that? So simply it's going to be 0.25 omega. But one of the disastrous thing had happened is that it had been in degrees, but this had been in radians. This had been in radians. If you want to get the value of omega, only one possibility you have. Either you change minus 180 minus 90 into the form of radians, either you change minus of 0.25 times of omega into the form of degrees. We know 180 degree is equals to of pi radian, which we know already. So obviously 1 degree is simply going to be pi divided by of 180 radian. Yes, or in the another way I can say, see, pi radian is equals to 180 degrees, so 1 radian is equals to of 180 degree divided by of pi. 180 degree divided by of pi. Yes, so we can understand it. So now here, rather having pi radian, we had 0.25 omega radian. So what we could have done over here, we can simply replace this as 180 degree divided by of pi getting multiplied with 0.25 omega. I would like to have the input from each one of you. What we had the value of omega over here. I would like to have the input from each one of you. Exactly the value of omega which we had over here. So the two people had given the answer, only one people had given the answer, and that had been the Amit Kumar. Amit, tell me, what had been the exact most answer of the omega at which the gj omega hj omega was crossing through the negative real axis of the given plane. So what we can do, we can shift this minus 180 towards left hand side. 180 had been the common, we will knock them out, and there I would be getting the omega. Let's take it had been omega a. So we know exactly at which operating frequency the phase offered by the system is being exactly minus 180 degree, or the operating frequency at which the gj omega hj omega was crossing through the negative real axis. And once you know this frequency, I think my work is almost done. And now we had to talk about what we had been given. Passes through the negative real axis, my dear friend, the distance from the origin itself, it's been the magnitude. And if you know at which particular frequency the gj omega hj omega crosses through minus 180 degree or negative real axis, by default you would be able to get its magnitude. So what I am saying, you had to have the reference of omega a, and then you had to get the magnitude offered by this system. May you know what would be the magnitude offered by this system? First of all, whenever you have this factor e to the power of minus std, at any operating frequency, the magnitude offered by the system would always be 1, or the magnitude offered by this factor would always be 1. Why so? Again the same thing. If we'll talk about its real part, that had been cos of theta, and similarly if we'll talk about its imaginary part, that had been minus of j sine of theta, and once you'll take its magnitude, the magnitude is simply going to be root over of its real part, it's been cos square, and similarly imaginary part, that had been sine square. And for all similar values of theta, root over of cos square theta plus of sine square theta would always be 1. Yes, no? So put together, this would not be affected at all, only magnitude of s has to be taken place, and once you will take the magnitude of s, that's going to be only omega, and we had to calculate that value at omega a. Once you will feed that value, the result which we are supposed to get, I have already done the calculation, is being 0.5. So magnitude part is being known, 0.5. The magnitude had been 0.5, and as the magnitude had been 0.5, that means you can have the reference of a circle, whose radius is being 0.5, whose radius is being 0.5, yes, 0.5. And if we'll talk about the intersection over the negative real axis, one thing has been quite sure, sir, it had been minus of 0.5 and the imaginary part had been simply 0. Imaginary part had been simply 0. Sir, omega is same as the omega PC, yes. So far I did not talk much about the phase crossover frequency as well as the gain crossover frequency. That is why I don't want to bring the big word, at least at the very preliminary phases. So that's why I did not bring the concept of the omega PC over there. Otherwise, many of the students who do not have the fair idea about the phase crossover frequency as well as gain crossover frequency probably may go into the big trouble. Omega as per the Amit is being 6.28. Yes, so pi is almost 2 times of 6.28, and once we'll take its ratio, the resultant had been 0.5. But as we have been talking about the intersection over the negative real axis, where obviously the real part is gonna be pure negative, the answer has been same. Pavandip Singh, thanks dear. So again, I would like to have few of the highlights of this problem. Whenever they had been talking about the intersection point over the, I repeat, whenever they had been talking about the intersection point of Gj omega, Hj omega, maybe over the negative real axis, positive real axis, positive imaginary axis, negative imaginary axis, always take the reference of the angle line. Just try to find at which value of omega it had been crossing to that particular angle. Like here I took the reference of 180 degree. And once you know the value of omega at which it had been crossing to the minus 180 degree, taking the reference of that omega, I can get its magnitude. Straight away there is no other way. Could you really understood what exactly I have been talking about? Obviously, sir, we had been almost understood what exactly we had been talking about. Yes. So I think it's the right time to move forward, taking the next question. Here goes the next question of the day. Again, I would say it's not that great question, but many of the students do not have much idea about this sort of problem. This problem had been experienced by the electrical people. In year of 2010, the problem was framed by IIT Guwahati. Let me read this problem carefully and we would try to decode all of the important aspects which had been asked within this problem. The problem states, the frequency response. Obviously, it had been a frequency response because once you will see option A, B, C and D, it had been a polar plot, and the polar plot is being drawn over the polar graph paper where we draw the how the magnitude as well as the frequency of the OLTF system is being changing as the value of omega is being changing continuously from 0 plus to infinity plus. What does that mean of it? That means we had been talking about the variation of omega, or I can say it had been a frequency response over the polar plot or polar graph paper. Agreed? Polar plot or polar graph paper. Yes. The GS is being clearly given in this problem. It's been 1 divided by S getting multiplied with S plus 1 getting multiplied with S plus 2 plotted in the complex Gj omega. The same thing, the S has to get replaced with the J omega. Earlier it had been GS, that means the plane of study had been the S plane. Now the plane of study had been changed to the J omega. For omega had been changing from 0 to infinity, nothing had been given, so obviously I would take 0 as a positive side of 0 and similarly infinity as a positive infinity. That means they had been talking about the polar plot only. The 4 different options were attached along with this problem. Tell me what could be the best most answer which we would have after smashing this problem out. I would like to have the input from each one of you. So here goes the question. Tell me what would be the best most answer which we are going to have over here. See, let me take the reference of the open loop transfer function, and that had been GS is equals to of 1 divided by of S plus 1, S plus 2. If nothing had been given regarding the HS, no, just take the approximation that the type of the system is being UFB system, unity feedback system. That means the value of HS is being unity. So in future the GS itself is being GSHS. So GSHS is being 1 divided by of 1. Otherwise, the statement of the problem itself was quite self-explanatory. What they say? The frequency response of GSHS plotted in the complex plane. So this has been the first outcome. This has been the first outcome. Similarly, in the same sequence, let me focus over the next step. In the next step, what we are going to do, the plane of study would be shifted from the S to the j omega. So what we have been doing over here, S has been mapped over the j omega, and hence all of the component of S would get replaced with j omega. J omega. It's been j omega. Yes, so we can understand it. We can understand it. So the answer have started coming. As per the Amit, answer had been D. As per the Anindya Bose, the answer had been A. I want at least one unified answer. I want at least one unified answer. Now, in next step, what we are going to do, at least we are going to filter out, we are going to rule out few number of options out of the 4 options which had been given along with this problem. My dear friend, this factor j omega, when it would get activated towards a low frequency of operation, towards a high frequency of operation, or this component would be activated throughout the operating frequency of omega, at least in terms of angle. No, 1 upon s supplies the angle of minus 90 throughout the all possible values of omega, whether the omega had been towards a very lesser operating frequency or towards a very higher operating frequency. So one thing has been quite sure, this factor now 1 upon j omega is going to introduce the initial angle as minus 90, and similarly if we will talk about the final angle, how much final angle we are going to have, and now if we will talk about the differences between the number of open loop zeros as well as number of open loop poles. The number of open loop zeros are how many? 0 they had been, and the number of open loop poles how many? 3 they had been. So if we will talk about the initial angle. So initial angle of the polar plot would be decided by the type of the system. If there had not been any introduction of the negative sign, because somewhere the negative sign do come, no, because of that there could be the shifting. Initial angle is being defined by the type of the system. This system. It had been the type 1 system, and hence the initial angle is gonna be minus 90 degree. So may I know the out of 4 different options which had been attached along this problem, which had the initial angle as minus 90? Obviously, this has the initial angle as minus 90. This had the initial angle as how much? How much it is? Plus 90, or you can say minus 270. B had been ruled out. Initial angle had been plus 90 or minus 270. It had been ruled out. So obviously, you had been left with the A as well as D, where the initial angle had been minus 90. Many of the students would also think, sir, why you are saying that initial angle had been minus 90? What I am saying, if the omega at omega is equal to 0, the magnitude of the system had been quite large, it had been reaching towards infinity. So if you will take a very small look angle, no, very small look angle, then also you will see this polar plot had been tangent over the angle line, and that had been angle is equals to minus 90. So many of the students used to think that whenever you have this sort of plot, then only you will say at omega is equals to 0 or the initial angle had been minus 90, but this is not the case. This also had the initial angle as minus 90. Anyways, rub this out. Just a minute. Let me rub this out. Could you really understood what I am saying? So initial angle had been minus of 90. That had been quite sure. May I know what would be the final angle? The final angle is simply going to be the final angle in the standard form, final angle, which we get in case of polar plot is simply equals to of 90 minus of number of open loop zeros minus of number of open loop poles. How many number of open loop zeros we had? Sir, we don't have any open loop zero, that had been 0. Total number of open loop poles, how many they had? So obviously, sir, it had been 3. So 0 is getting subtracted with 3, the result would be minus 3. Minus 3 is going to get multiplied with the 90, the result would be minus of 270. And you can see in option A as well as option D, the final angle had been minus 270, or I can say the complete polar plot was ending taking the reference of the minus 270 degree angle line. minus 270 degree angle line. Only one difference we had. May I know what is that? What is that? And that had been at omega is equals to 0, the polar plot was tangent over which vertical line? Whether the vertical line had the worth is equals to minus 3/4 or the vertical line had the worth is equals to of minus 1/6. Tell me what would be the best most answer for this given problem. So at least out of the 4 different options, we could rule out the option B as well as option C in terms of their final angle as well as the initial angle. Their initial angle had been somewhere plus 90, similarly plus 90, which is not true, and even their final angle were somewhere plus 270, which was not true. So you had been left out with the option A as well as D only. And now if we'll focus over the option A as well as D, there had been the little bit change. What had been that? And that had been at omega is equals to 0, we had a reference of a certain vertical line which was becoming the tangent over the polar plot, and that vertical line was, let's take x is equals to of minus 3/4. X is equals to of minus 3/4. Whereas in option D, the x is equals to of minus 1/6 was becoming the tangent over the polar plot at omega is equals to 0. At omega is equals to 0. Can you tell me how exactly we will able to get at which x is equals to minus 1/6 or x is equals to minus 3/4, the given system would offer a tangential component over the polar plot at omega is equals to 0. At omega is equals to 0. I would like to have the input from each one of you. So this has been the specification. What we are going to do over here, we are going to bring this problem towards the next working page, and we would try to solve this problem step by step. The OLTF had been 1 divided by of s into s plus 1 into s plus 2. S plus 2. Yes, sir, we are able to understand it at least at this moment of time. Now in next step, my basic agenda is to segregate the real part as well as imaginary part separately. Okay, sir, we will do so. For that, what we are going to do first, we are going to replace s with j omega. It had been j omega plus of 1, and it had been j omega plus of 2. Okay, sir. Once the multiplication starts taking place, j omega gets multiplied with j omega, the resultant is simply going to be minus of omega square, and here it had been j of omega. And now the same thing takes place, and it had been j omega plus of 2. Again the multiplication would take place. So let me do one thing, let me multiply the minus omega square with the j omega plus of 2, then we would multiply j omega with the j omega plus of 2. So when the multiplication takes place, the factor which do come into the picture, it's been minus j omega square into of omega, that would become omega cube, and here it becomes minus 2 getting multiplied with the omega square, and here again the same thing takes place, the j gets multiplied with the j, that would become iota square, and the iota square is very same as minus 1, so minus 1 gets multiplied with omega into omega, that had been omega square, and end of the day we are going to have 2 times of j omega. In the same sequence, let me move forward. Let me segregate the component of real as well as imaginary part. So what had been happening over here, minus 2 omega minus omega square had been the like term, so why don't we club them together? Yes, sir, we have done it. So it had been minus of 3 times of omega square, which had been a pure real part. Similarly, if we'll talk about the imaginary part, what had been the imaginary part over here? You could have taken iota component out, and the factor which had been left out, it's been 2 of omega minus of omega cube. Yes, minus of omega cube. We can understand it. My dear friend, for this problem, you need not to calculate the value of omega PC. Yes, you need not to calculate the value of omega PC. In the same sequence, let me move forward. And now what we have been doing over here, now my responsibility is to, I repeat, my responsibility is to keep the real as well as the imaginary part separately. And once we do so, what we would do? We would do its multiplication, or we would do the so here I would do the multiplication with the complex conjugate of the denominator as well as numerator. So end of the day, towards numerator side we are going to have this factor. It's gonna be sort of this. Agreed? And towards denominator side we are going to have a positive real quantity. I repeat, we are going to have a positive real quantity. Positive real quantity. Yes sir, we can understand it. And one thing if you would like to understand, when the omega had been 0, I repeat, when the omega had been 0, what had been the conclusion over there? And similarly, what had been the real part and what had been the imaginary part? What had been the imaginary part, what had been the real part? And from there, what you had to do, you had to find its real as well as imaginary part. And once you'll find its real as well as imaginary part, you will find that at omega is equals to 0, minus 3/4 had been the tangent over the given polar plot. Anyways, the same kind of the problem had been taken into the last class. You can take the reference of that question. Should I repeat once again what had been the complete thought process behind this complete problem? At very beginning we had the OLTF system. Obviously that had been supplied in the S domain. We have converted into the frequency domain by replacing S is equals to of j omega. That we have done it. From there I have just had a eye view that what would be its initial as well as the final angle. With the help of that I could figure it out. The option C as well as option B could not be the answer because their initial as well as final angle had not been matching with our requirement at all. So that had been ruled out. Now once you will focus over the option A as well as option D, only and only one difference we had. What had been that? At omega is equals to 0, obviously the magnitude is going to be infinity, because when you would be feeding omega is equals to 0, the S would also become 0, and as the denominator is 0, numerator had been 1, so magnitude is going to be infinity. What does it mean by the magnitude to be infinity? That means that point of interest at omega is equals to 0 would be kept at a very, very far distance from the origin. That could be somewhere here, that could be somewhere here, that could be somewhere here, but one thing has been quite sure, at omega is equals to 0, the angle offered by the system is being minus 90 degree, so obviously it is going to be somewhere here. But what I have seen many of the students used to by heart, sir, the curve would be like this, but it's not that straight. I am agreeing that the angle which had been offered by the system is been minus 90, but here also the angle which had been offered by the system is been minus 90 because it had been coming from very bottom side and still the angle is been minus 90 degree. Yes, if you will take a little bit variation over the angle, no, is still at omega is equals to 0. This line as well as this line would be tangent to each other. Yes, no? So end of the day, one thing has been quite sure, you have to focus over its real as well as imaginary part by keeping omega is equals to 0. Once you do so, no, you will find its real part would be precisely equals to of minus 3/4 and its imaginary part is gonna be infinity. I repeat, you have to do it by your own. You have to take its real denominator, you have to talk about its numerator, you have to do all stuff of calculation. I would like to have the input from each one of you. You guys would be able to do it by yourself, or if you want my assistance, definitely I would be able to give that assistance also. Will you be able to do so? Students, will you be able to do so? If you're not able to do so, I would be giving little bit help to you guys. Tell me. Would you be able to do? Just do one thing. Segregate the real part, segregate the imaginary part, and then feed omega is equals to 0. You will find the component of imaginary part would become infinity, and similarly the component of real part would become minus 3/4. Amit, yes sir, I did not get you actually, Amit. Whether you are asking me to solve it completely or whether you guys would be able to manage this problem by your own. Actually the complete input I did not understood what exactly you had been meant for. Tell me. Whether you guys want me to solve this problem completely, in that case I would solve this problem completely. We can do it now. Sir, we will do it by its own. Okay, then it's fine. Then it's fine. Just focus over this part. This would become its real part. This would become its imaginary part. Feed omega is equals to 0. Once you will feed omega is equals to 0, no. Here this part is going to be simply infinity. Why this part is simply going to be infinity? You will see the residue part of omega would be left out towards the numerator. That would not be knocked off. As you can see here the power had been 2. Here the power had been 3. So one additional omega would be there. And once you will feed the omega is equals to 0, this part is going to be infinity, whereas this part is going to be the finite value, and that had been minus 3 by 4. That had been minus 3 by 4. So I think it's the right time to take the next question. So here goes the next question in front of you. This problem had been framed by IIT KGP. The problem had been experienced by the electronics people in year of 2014. Read this problem carefully. The problem states the consider the feedback system shown in the figure. The Nyquist plot of GS is shown which one of the following conclusion is correct. That means you had given a standard negative feedback system in the terms of its block diagram representation, and at the same time it's what, although they have called it where consider the feedback system Nyquist, yes, the word had been Nyquist. Even they say polar plot, then also you had to take this as a Nyquist plot, because this complete structure had been the closed structure, and the closed structure takes place only in case of Nyquist plot, where the value of omega starts from 0 plus and comes back to 0 plus. This has been the Nyquist plot. So what I am saying, this had been the standard form of the negative feedback system. This has been the corresponding Nyquist plot, taking the reference of both out of the 4 different options which had been supplied along with this problem, which could be taken as the best most option, which could be taken as the best most answer. Again, I would say this is not a very easy problem, but even if you put a little bit thought process over this problem, you would be able to smash this problem out. It's not that difficult also. GS is an all pass filter. GS is a strictly proper transfer function. GS is a stable and minimum phase shift transfer function. The closed loop system is unstable for sufficiently large and positive K. This has been the reference of the block diagram of the given system. This has been the reference of the Nyquist plot for that given transfer function, and taking the reference of these 2 blocks and two figures, you had to find what could be the best most answer for this given problem. What could be the best most answer for this given problem? So the answer have started coming. As per the Amit Kumar, answer had been D. As per the Anindya Bose, the answer had been D. Anyone else apart from the Amit as well as Anindya? This has been the 4th question of the day. Focus over the option A first. What the option A states? In option A, they had been referring the all pass filter. What does that mean by the all pass filter? The name itself is self-explanatory. It had been a special category of the filter which passes all of the frequencies with the same attenuation or maybe with the same gain. That means no partiality had been made towards any operating frequency, maybe towards a higher operating frequency, towards a lower operating frequency, or the intermediate operating frequency. Or I can simply say the gain offered by the given OLTF in frequency domain must be independent from the frequency itself. It must be merely a constant value. And if it had been merely a constant value, that means the gain offered by the system had been independent from the operating frequency omega itself. Whether this has been the case or not, no my dear friend, this has not been the case, because as the omega had been changing, exactly I won't be able to say in which direction the omega had been increasing, but one thing has been quite sure, as you had been moving over this plot, the distance from, what I am saying, the distance from the origin is being keep changing it had been, keep changing, and you can see here the distance had been least and it had been keep increasing, and here the distance has been maximum. So one thing has been quite sure, as the distance of the polar plot from the origin is being keep changing, what does that mean of it? That means the gain offered by the system is being keep changing. From here to here the gain is being keep increasing, here to here the gain is being keep increasing. I can say the gain offered by the Gj omega, Hj omega is being keep increasing, in the same direction. It has been keep decreasing in the same direction, in the keep decreasing. So can I categorize this Nyquist plot under the all pass filter system? No sir, I won't be able to categorize it. Obviously A had been ruled out. If I take the reference of a system, let's take the system is being 1 minus s divided by of 1 plus s. If I'll take its magnitude, obviously in frequency domain, what's going to be its magnitude? It's going to be root over of 1 square plus of omega square divided by root over 1 square plus of omega square, that had been 1. And once we would try to draw its polar plot, how its polar plot would look like, that we have already seen earlier. Anyways, forget about its polar plot. If we'll talk about its Nyquist plot, it's going to be a pure circle. And one of the best thing regarding this circle, the distance from the origin would be constant, or I can say this would be a circle having the center as origin, but this has not been the case over here. Agreed? This has not been the case over here. So obviously A had been ruled out. Similarly, the option B which had been given along with this problem is it had been a strict proper function. What does that mean by the strict proper function? Let's take, you had a OLTF GSHS, had the two part of numerator as well as part of denominator. Numerator had been referred as a n of s, and similarly denominator had been referred as a d of s. The roots of its numerator is being defined as zeros of this OLTF, and similarly roots of its denominator is being defined as poles of this OLTF. If pole or the number of poles are being greater than the number of zeros, in that case the system is said to be what? Strictly proper function, or strictly proper transfer function. And one of the best thing regarding the strictly proper transfer function is the degree of denominator would be heavier than the degree of numerator. Yes sir, I can agree on that, my dear friend. As the number of poles were greater than the number of zeros, so obviously the degree of denominator would be heavier than the degree of numerator. So in omega tends to infinity, when the degree of denominator is being greater than the degree of numerator, at omega tends to infinity, the magnitude offered by the system would become 0. I repeat, magnitude offered by the system would become 0. So what I am saying, for strictly proper function or strictly proper transfer function, when the omega had been tending towards infinity, the magnitude offered by the system precisely goes to 0. This has been the basic properties of the limit when the limit had been tending towards infinity. If you are not able to understand, you yourself would be able to understand. Here, if I have taken limit x tends to 0, x divided by of x plus 1. Towards numerator and denominator, we had the same degree, and that had been the degree as 1. If you will calculate its worth, by default, it's going to be merely a constant value, neither 0 nor infinity. Now, if you have taken another situation where the degree of numerator had been larger than the degree of denominator, resultant would definitely be infinity. And now, if you will take the reverse case, when the degree of denominator is being greater than the degree of numerator, definitely resultant would be 0. That had been the basic properties which we have dealt in mathematics into the great detail. So one thing has been quite sure, In this problem, as we have been dealing with the strict proper function, as far as the option B is being concerned, the degree of denominator had been heavier than the degree of numerator. In that case, at omega tends to 0, the magnitude has to reach to 0. And one of the best thing regarding this Nyquist plot, at any operating frequency omega, this Nyquist plot has not gone to the origin, and until and unless it had not gone to the origin, the magnitude would not become 0, because stating the magnitude had become 0, that means that polar plot or the Nyquist plot has reached to the origin of this plane, origin of this plane. So sir, no. Yes, what I am saying, in future, if this could have been given in this way, no. So what it's been saying, at omega is equals to 0 plus, you had been starting from a certain finite value, forget about it. But at omega is equals to of infinity, no, the magnitude of the system had become 0. That means it had been a strictly proper function. Tell me whether it had been a strictly proper function or not. Yes sir, it had been. And once you will draw its polar plot, it would start from minus 90 and it would go to the minus 270, but still at omega is equals to infinity, it would be submerged at origin, because it had been a strictly proper function. Similarly, even if you take the reference of 1 divided by of s plus 1, no, here also the same thing. At omega is equals to 0, the angle offered by the system is simply going to be 0. The magnitude offered by the simple system is simply 1. It would start from here. And as the value of omega would increase, definitely it would be providing more and more lag. And as it has been providing more and more lag, obviously this point would start shifting in clockwise direction. Magnitude would be keep shrinking as the factor of the omega had come towards denominator side only. And as the omega goes infinity, what would happen? Again, it would submerge to the magnitude as 0. But at least here, nowhere this complete Nyquist plot had been trying to submerge over the origin. That means never ever the magnitude had become 0. That means even this had also been ruled out. This has also been ruled out. Now GS is a stable and minimum phase shift system. No, we cannot have any conclusion. And anyways, you guys did not have much idea about the NMPS and MPS system. So I think this is not the right time to discuss more about the option C. So you can just rule out the option C for the time being. Just focus over the option D. The closed loop system is unstable for the sufficiently large and positive k. See what had been happening, as the value of k would be increasing in the positive sense, what would happen? This complete plot would be expanding from its place. Obviously, as the k had been increasing into the positive sense, there would not be any phase shift introduction over the system, only the magnitude will increase, and as the magnitude would increase, this complete bubble would start expanding from its place. And after certain gain, what would happen? It would also cross -1, and as the system crosses -1, if I take the reference of n is equals to of p minus z, if nothing is being given, I will presume the system had been a stable system when it was in an open condition. So p could have been taken as 0, and I would try to have the n as what? 1, and once you will feed that, the z had become 1, the system had become a unstable system. Could you really understood what exactly I have been talking about? As it has been keep expanding from its place, -1 would get encircled. May I know the encirclement, would it be a clockwise in direction or anti-clockwise in direction? Obviously sir, it had been clockwise in direction, so n would be taken as -1. P had been 0, z would become 1. System would become a unstable system. So out of the 4 different options which are being attached along with this problem, so the best most answer which we can have out of this is being option D. I won't say it's been a difficult question, but I can simply say this sort of problem may come in near future, because in near future they are not going to ask any straight questions. Yes, no? Okay then. I think we should move forward into the next question now. So here goes the question number 5. A unity feedback system has the open loop transfer function 1 divided by of s 2s plus 1, the polar plot for the system is being. The 4 different options were attached along with this problem. Tell me what would be the best most answer. I would like to have the input from each one of you. Sir, when will you start EMFT for the EC? Anyways, the crash course for the EMFT is supposed to come from the electronics, probably from the very starting day of the upcoming month. And probably there my mode of communication would be completely in English, because I am going to take that classes on admin gate academy. So probably from the 1st of August we are going to start the crash course on EMFT specifically for the electronics people only. That means I would start from the Maxwell equation, taking the reference of Maxwell equation. I would simply jump it to the different boundary conditions. We would also talk about the Helmholtz equation. We would talk about the oblique incidence, skin depth, propagation of the wave in the different medias. We would talk about the transmission line. We would talk about the waveguides, and end of the day we would also be talking about the antennas. Definitely from the first day of the August probably we are going to start the crash course on the EMFT. So I think it's the right time to take the question number 5. Tell me what could be the best most answer for this given problem. What could be the best most answer for this given problem? Once you read this problem carefully, one thing has been quite sure. There had not been any component of minus sign over here. I can say it had been the standard or MPS form of the system. I repeat, it had been a MPS form of the system. And as it has been the MPS form of the system, few of the important conclusion I could have derived out of it. As it had been a type 1 system, so what's going to be its initial angle? The initial angle is simply going to be minus of 90 degree. Option A has been ruled out, because here the initial angle, how much it had been? It had been taking the reference of positive imaginary axis, that had been plus 90. Similarly, B has also been ruled out. You had been left out with the option C as well as D. Again, it had been a type of MPS system. The second important conclusion we could have derived out of it, it's been the difference between the number of zeros minus some pole. How much they had been? The number of zeros had been 0 and the number of poles had been 3. And once we multiply this subtractive factor with a 90 degree, the resultant had been minus 270 degree, and that would be the final angle which would be offered by the given open loop transfer function. So obviously it's going to be minus of 270. Again, the C and D had been the option which had been left out with us, because at omega is equals to infinity, it had been taking the reference of minus 270 degree line, and similarly here also it had been taking the reference of minus 270 degree line. So option A as well as B has been ruled out. So in this problem they had been talking about, I repeat, in this problem they had been talking about the magnitude, or I can say the intersection of this polar plot over the real axis of the S plane. The same sort of problem which we had probably as a first or the second question of the day. Tell me what would be the best most answer over this problem. Again, you find the value of omega PC, and that is nothing but the frequency at which the angle offered by the system is minus 180 degree, or I can say the intersection over the negative real axis of the polar plot. Taking the reference of that omega, we would again find the magnitude offered by the system, and end of the day our work is done. Yes, get the answer done. So as per the Amit, the answer is being C. I would request to each one of you, try to increase your speed. Again, the same thing has to be done. You had to find the value of omega at which the system is being crossing through the negative real axis, because we had been finding the magnitude over the negative real axis, no? So what had been happening, just try to understand. The omega is being keep increasing. So at certain operating frequency omega, the given polar plot is being crossing through the negative real axis, and at negative real axis the angle offered by the system is simply going to be minus 180 degree. And now they had not been talking about the value of omega, I repeat, the minus 2/3 is not been the value of omega. this has been the magnitude, or this has been the exact point at which the intersection had been taken place. So what we can do, we can take the value, or we can calculate the value of omega at which the system crosses through the negative real axis, and that had been minus 180 degree. And once we are done with that, we can feed that value of omega over this system, and once we get its magnitude, now we can know at least one thing: the magnitude is being done, but that magnitude had been towards negative real axis, so the minus sign would also get introduced. Sir, will EMFT will be taught in the same manner as the control system? Exactly, I could not figure it out in which sense you had been talking about. In which sense you have been talking about. So till this point, probably each and everything must be. Just focus over the angle offered by this system. There would not be any introduction of the angle because of its numerator. Because of S, there would be the introduction of minus 90. Because of 1 upon 2S plus 1, there would be the introduction of 10 inverse, the imaginary part that had been 2 omega, real part that had been omega, and here it had been minus of 10 inverse, imaginary part that had been omega, real part that had been 1 is equals to, we had to compare it with minus of 180 degree, minus of 180 degree. So what we can do over here, the minus 90 would be shifted towards right hand side, minus 180 plus of 90 would become minus of 90, minus and minus would be ruled out, and the factor which had been left out is being 10 inverse of 2 omega minus of 10 inverse of omega is equals to of plus of 90 degree. And now what we can do, it had been the inverse trigonometry which we have used earlier. 10 inverse of A minus of B is equals to of 10 inverse of A minus of B divided by of 1 plus A into B, and that had been 2 omega square, and that had been still plus 90 degree. And when the tan inverse is being shifted towards right hand side, we know the tan of 90 is being infinity. So one thing is been quite sure, the factor which we had over here has been 1 plus of 2 omega square. 1 plus of 2 omega square, omega divided by 1 plus 2 omega square. Yes, no? Now what we can do over here, just to make the equality both other side, we have taken the inverse both other side. Once we do the inversal both other side, we had this sort of thing. Yes, it had been omega. Any mistake had been done over here? Yes, the mistake had been done. It had been positive, no? It had been positive. Yes, mistake had been done. It had been negative over here. And here also it had been negative. Here it had been negative. So here it had been negative, negative, and negative. And here it becomes 0 now. Here it becomes 0 now. So the value of omega at which the polar plot was crossing to the negative real part is being 1 upon root 2, 1 upon root 2. So what we had to do, we had to find the magnitude of Gj omega at omega is equals to of 1 upon root 2. And even we have talked about this thing in the much detailed way. Whenever you have been dealing with the complex function, you can find the magnitude of the individual constant, and now end of the day, the magnitude what you get, that's going to be the magnitude of the complete transfer function. So rather taking its real as well as imaginary part and then taking square root of its real part as well as imaginary part, no, you just focus over the magnitude of this, magnitude of this, magnitude of this, whatever the magnitude of the individual component we get, no, you just multiply and divide in the fashion it had been made over here. Because this has been the basic property of the complex function which we have dealt over the engineering mathematics. So the magnitude of 1 is being simply 1. Similarly, the magnitude of S is simply be omega, and that had been 1 upon root 2. 1 upon root 2. And similarly, if we'll talk about the magnitude of this, is what's going to be the magnitude of this? It's simply going to be the 1 had been raised to the power of 2, that had been 1. 2S, the S is being j omega, the omega is being 1 upon root 2. So simply it's going to be how much it's been? It's been omega into root 2. Omega into root 2. Simply it's going to be root 2, which has been raised to the power of 2. Everything is being taken care. The S is simply again j omega. Omega is being 1 upon root 2, which would be raised to the power of 2. 2 plus of 1. And once you will do its complete multiplication, the resultant which we are going to get, how much, tell me? How much resultant we are going to get? Probably the answer which we are supposed to get, it's been minus 2 by 3. Yes. So the answer which we are going to get, it's going to be 2 by 3. and as we had been talking about the intersection over the negative real axis, so minus would be added over here. So it's been minus 2 by 3. Minus 2 by 3. So the best most answer which we have been getting out of this problem is been minus 2 by 3. Minus 2 by 3. Agreed, no? I think it's the right time to move forward, taking the next question. Just a minute. So let me go upwards a bit. I would say it's not a very difficult question, but a very, I can say, a smartly designed problem. Read the problem carefully and tell me what would be the best most answer for the question number 6. This problem had been experienced by the electrical people in year of 2016. The problem was framed by IISc Bangalore. IISc Bangalore. This has been the next question. Read this problem carefully, and within 2 minutes you guys must be able to answer it well. Within 2 minutes you guys must be able to answer it well. The problem states the loop transfer function, that means you go forward, you come backward. Towards forward side you get the forward path transfer function, that's been G, and similarly once you come back you get the feedback forward path transfer function, that's been GH. Put together G into H and put together I can say it's been the OLTF. GSHS is equals to of S plus 3 divided by S square getting multiplied with S minus 3. Take the Nyquist contour in the clockwise direction. Then the Nyquist plot of the GSHS encircles minus 1 plus J0. 1 in clockwise direction, twice in clockwise direction, once in anti-clockwise direction, twice in anti-clockwise direction. Twice in anti-clockwise direction. I would like to have the input from each one of you. What could be the best most answer for this given problem? I would like to have the input from each one of you. What could be the best most answer for this given problem? For this given problem. See, I know there would be the two category of the student and they would have the two different methodology. First student, what they would do, what the first person would do, he had seen the Nyquist plot now, without giving any second thought, simply he would jump into the Nyquist plot. First he is going to draw the polar plot, and the extension of the polar plot he is going to draw the Nyquist plot. And from there onwards he would be talking about how many times the encirclement of the minus 1 plus J0 had been taken place. But such a complex system you had. Not only that, even the minus sign is also got introduced. Because of that, there would be a substantial impact over the phase which would be provided by this OLTF. And the second person who had been the smart person, probably going to perform well in GATE, what he is going to do? He would do the reverse engineering. And as per the reverse engineering, he would recall, sir, as per the principle of argument, stability of the system is being assessed with this formula, n is equals to of p minus z. N is equals to of p minus z, where the n had been the number of encirclement of the critical point. Obviously, if we have been talking about the stability of the closed loop system, that critical point used to be minus 1 plus J0. At least this point is being clear, sir. No issue. We can go forward. Similarly, what had been the P over there? The number of poles towards right hand side. Number of poles towards right hand side. Poles towards right hand side. Right hand side. Which pole? Open loop pole. S plane. And here the number of closed loop poles towards right hand side. Number of closed loop poles towards right hand side. Now the person, what he is doing, he has not been focusing over the Nyquist plot at all. What he has been doing, he has been just focusing over this mathematical expression. In this mathematical expression, at least the person knows about the number of open loop poles the given OLTF used to have towards right hand side of the S plane. Because of S minus 3, we would have one pole towards right hand side of the S plane. So the value of P had been 1. And now the person is going to get the number of closed loop pole towards right hand side with the help of either of the method which we have used earlier. And probably the simplest form of the method which we have used earlier is being Routh orbit. So what he is going to do, rather calculating or rather drawing the polar and then extension of the polar Nyquist, and then to get the value of n, he had been focusing over the P and Z, because this calculation would become too difficult and its plot would become too difficult. Agreed, no? So what we are going to do over here, we are going to create the characteristic equation, because we had been talking about the stability of the closed loop system. What's going to be the characteristic equation? It's simply going to be 1 plus of GSHS getting compared with 0. And now the S gets multiplied with S square, it becomes S cube minus of 3S square plus of S plus of 3 is equals to of 0, is equals to of 0. So obviously the polynomial is being created, had been in order of 3. Let me create Routh-Hurwitz table. So what are the factors we are going to have over here? It's going to be 1. Here it's going to be, here it's going to be minus of 3. Here it's going to be minus 3. Here it becomes 1. Here it becomes plus of 3. Plus of 3. Agreeing, sir? No issue. No issue. Now the cross multiplication and the compression would take place. Minus 3 gets multiplied with 1. That's going to be minus of 3. And then 3 gets with the 1. That becomes minus of 3. Minus of 3 divided by minus of 3. So minus of 6 divided by minus of 3, that would become plus of 2. Plus of 2. And here it becomes 0. Here it becomes 0. End of the day, the last result which we are going to get, it's simply going to be 3. The last result which we are going to get, it's simply going to be 3. How many sign changes we had, my dear friends? The 2 number of sign changes we had. 2 number of sign changes we are going to had. So obviously the Z becomes 2. 2. Z becomes 2. And 1 and 2 got subtracted. 1 and 2 got subtracted. So result had been minus of 1. Result had been minus of 1. So may I know what would be the best most answer for this given problem? Obviously, minus sign, that means the enclosement is being clockwise, and 1 indicates there had been only once minus 1 plus J0 got enclosed. So the best most answer which we are going to have for this problem is being A. So what I am saying, there could have been the 2 different methodology. The first methodology could have been the robotic methodology, like we do the programming of the robot. The robot do not have its own understanding, at least until and unless the AI is not been fed within the brain of the robot. So whatever the process is being fed now, the robot is going to perform each and every task with the help of those processes only. So if you guys had been belonging in that range now, or in that segment, you could have used the manual method of the polar plot and then Nyquist plot and then the value of n. Definitely the calculation would have been very difficult. Calculation would have been very difficult. Agreed? So okay, we will do one thing. We would go with few more number of questions since tomorrow's class. Probably the question number 7 we are going to have, as at the same time the question number 8 we are going to have. So this has been the agenda of the today's class. We would meet with the next agenda precisely at the same time. Till then, bye bye, take care.